Alright, had a little accident. The camera just collapsed on me. So there's going to be more than one video for gay Lussac here. I guess I got too carried away talking about the snow. Anyways, okay, so I got the 82.5 on that last one. And so we're going to let this go to 90. And then we'll be done with the actual experiment. And then we'll look at the data and what to expect out of the data. It's 85. So 90 degrees is, so I just told you, so, multiply 180 plus 30, so it's about 210 degrees, almost boiling. Boiling is 100 degrees Celsius. My estimate is off, but it gives you a rough idea. So 87, I need to get 3 more degrees, and then we turn off the heat and I'll look at the data. I hope this is recording. And I can hear the water starting to boil. So the temperature of the water, the air is the same as the temperature, and the flask for the most part. There might be a slight difference. Okay, so it's almost at 90. Okay, and there you go. So I'm going to stop there, and then we'll take a look at the data. Okay, so I'm going to turn everything off here in terms of my apparatus. I kind of want to take care of this so that, because it's really near boiling and I don't want it to boil. So, so I'm actually going to get rid of the water so I get some hot hands to do this. And then I pour down the sink. Whoops. Okay, so now we're going to analyze the data. All right, so so I'm going to change the graph options, and I don't want to connect the points actually. I want to see what my points look like on the graph, and they kind of go up like this, and if you take a notice, is that the first couple points are actually kind of so you have these lines here and these guys up here. I think there might be these first 2 points I don't like. Now, typically you don't like to throw away data, but what I see is that there's enough information in this set of data here to think that this is good here. This up here, all right. These first 3 here, I think it had to do with the mistake that I didn't have it quite sealed well enough. And what I'm going to do is I'm going to, first of all, I want to make sure I save my data, okay, or have a way to keep it. So just in case I hit the wrong button. So typically what I ask my students to do is take a picture of it, and that's exactly what I'm going to do. I'm going to take a picture of the data, because that's a really important thing. All right, now what I'm going to try to do is I'm going to try to get rid of these first 2 points here and start from the 3rd point to come up with the relationship between pressure and temperature. Let's see if this works. Okay. There might be some way out to do it. Copy. All right. So what I'm doing here is I moved it to another graph, but that's fine. Okay, and then just replot it. That's not right. It's actually temperature. Hang in there. Boom, boom, boom. Okay. Okay, so here's our graph. Here's a better representation of it. So what I did, I basically wanted to transfer the data over onto another file to get a linear fit without messing up the other file. I was just afraid that I would accidentally close the file and then lose all my data. So I got rid of those 2 points, and now I have the data from about 35 degrees up through 90 degrees, and versus the pressure, and you can see it's a really nice straight line. And so what I want to do now is actually come up with the best fit line for that. Okay, and the way I'm going to do that is all right. If you were in a class, I would help you out with this, okay? But here's the information that we want. And this is really important in terms of how we're going to write this up. So the equation of this line is of the form y equals mx plus b, where y is the pressure and x is the temperature. The slope is 0.2877 kilopascals per Celsius. And the y-intercept is 87.91 kilopascals. The correlation, which tells us how good the data is, really good. It's 0.9999. Okay, so picking these data is really good. So what you want to do is you want to write that equation out in terms of pressure equaling temperature. So your equation is going to be pressure P equals 0.28, so let's go 3 digits, 0.288 kilopascals per Celsius, okay, times temperature plus the y-intercept 87.91 kilopascals. So I'm going to ask you to write that equation out to as well. Okay. All right. The next thing I want you to do is I want you to set set temperature equal to 0. Your equation. So I'll actually rearrange the equations in terms of temperature. So temperature equals, is that what I want you to do? Yeah, okay. So rearrange your equation in terms of temperature. So just put temperature on the left side of the equation and pressure on the other side. And hopefully you'll be able to do that. And then what I want you to do is, from the equation, what is temperature equal when pressure is equal to 0? Okay, and that will be on the quiz. Okay, so you take that equation, the original equation, pressure equals 0.288 kilopascals per second times temperature, or T, plus 87.9 kilopascals. Then rearrange that equation in terms of T. So what are you going to have to do? You're going to have to subtract B from both sides and then divide by the slope. Okay, and then what I want you to do once you do that is, for the value of pressure, put in P. For P, put in 0 and find out what the temperature you get. Now it should be negative something. Okay. Now what we're saying from that is that when there's at some temperature, at a really low temperature, there's no pressure. That means the particles are moving around, and we call that that's the lowest temperature you can get. So that is the lowest temperature, and so that's where we actually get the Kelvin scale from. You should get a number that's fairly close to negative, somewhere around negative 200 to negative 300. Typically, my classes have gotten around negative 320 or something like that Celsius. The idea is negative 273 because so this is a way to find absolute 0. So the value you get should be close to negative 273. All right, and so there'll be questions to deal with this. All right, so the next, so you have Boyle's, and now you have Gay-Lussac's, and so Gay-Lussac's is actually two videos because I crashed this one, and then Charles' Law will be on another video coming to you. All right, so that's it.